Hello class, hope everybody is doing well. We're honing in on the end here. Today's topic is going to be sequential analysis, chapter 6. And there's basically two types of problems. And you can see quiz 5 for this. The first type you already know how to complete. First type of problem, you're given a state graph, or a state table. You fill out the timing trace and you fill out a state graph. You also say, is it a Mealy or a Moore model? And remember, for Mealy, the output is function of state and input. So here we see, here's the output Z. It's a function of the state, has to do with state A, state B, state C, and it's a function of X, the input. Many of you have asked, or not many of you, but a few of you asked, how do I do this in the circuit? Well, if you kind of pretended that this wasn't here, note that there'll be 2 bits here. You'll have to assign a value for each state. We could go 0, 0, 0, 1, 1, 0, and 1, 1. You just pretend like this middle part's not here. And you do a 3 variable, Z. There's 8 rows here total if you split this into 2 different rows. And you would just write an equation for Z. Now this is the analysis, not the design, so we're not going to do that. And I sent out an email about that as well. And I'm going to do a full walkthrough of the quiz. I believe that'll be in a different video. So I want to keep this one, it's going to be rather short. So anyway, for Moore, output is a function, I need to learn how to write today, of state only. I'm doing this video a little later in the day. I think I'm kind of tired. I've been grading, and I'll try to write slower and make it more clear. Anyway, you know how to do this type of problem, or you should know how to. We've covered everything, so there's information out there for how to do all this. 2, second type of problem, given a circuit, fill in A, B, C above, and make the state table. That's the more challenging type of problem, and that's what we're going to go over today. And that's the first step. You've got to have the state table to know what the timing trace is going to do, what the state graph will look like, any of that. You can answer Mealy or Moore first. You just look at the circuit and look at the output Z. Does Z have X in it, or does it not? If X is going into a gate that goes into the output, then it's Mealy. If there is no X, then it's a Moore model. All right. So I'm going to be referring to some pictures in your book. You can, well, I will be referring to some pictures in your book, but first of all, like I said, I'm giving you step-by-step how to get through these. So, for analysis and you're given a circuit. Write the equations from the circuit. So that's the flip-flop input equations. So that'll be any D's, T's, J's, K's, S's, and R's. So D equals something, T equals something, whatever your type of flip-flops you have. And you don't have to have all the same type of flip-flop in the problem. And then what does Z equal? Two. Write the state table from equations and knowledge of flip-flops. Then 3, you answer the questions that are asked for, and that is generally state graph, timing trace, possibly a timing diagram. Alright, so we're going to do 2 examples of this. And here's where I'm going to refer to your book. Pull my book out of my stack of papers here. And we'll do a new sheet of paper for this. I just moved my clipboard, so I got to make sure it's aligned now with the video. It's pretty good. Page 381. This is the circuit we're doing, page 381, figure 6.22. And I'm going to write these down again in the notes, but just pointing out, here's D1. What does D1 equal to? Q1 and Q1 naught. Sorry, Q1 and Q2 naught, right here. And you just trace the circuit. What is this wire? It's Q1. What is this wire? It's Q2 naught. What is this wire? It's X. This is Q1 naught. What is Z? Easy. This one's just Q2 naught. What is D2? And then you OR those together, of course, for D1. And then for D2, we have X and Q1. So that's the first step. Let's see, does this even have an example number? I don't think this is an example number, this is just their description of how to analyze a sequential system. So, as we said, D1 is Q1, Q2 naught, or X, Q1 naught. D2 is X, Q1. Z is equal to Q2 naught. You should be able to answer at this point, is this a Moore or a Mealy model? It's Moore. Z does not depend on X. How do I know it does not, quote unquote, depend on X? There is no X in the equation here. If I look at the circuit, there's no X connected to Z. Alright, so again, just follow the process. That is step 1. Step 2. State table. A lot of the state tables I've put X over here. You can also split it up over here. You know, just understand what it means. You know, I'm kind of condensing things. There's less rows because I'm splitting my X equals 0 and X equals 1 here. Now here, I don't know what these are. That's what I have to figure out. I can go ahead and fill out Z very easily now. It's equal to Q2 naught. So put some rows in here. Keep everything aligned as possible. 1, 0, 1, 0. Kind of went overboard on some of these lines. I need some of the space to write a few more notes. So, what is the next state on a D flip-flop? How does it work? Next state is equal to D. Said equals equals because of Java background that we all should have. At least if you took Java 1 at UTC. Some of you may not have, but that's all it means. It's if, in an if statement, we say if equals equals. How do we get D? We plug in these values into the equation for D1 and D2. So 0, 0 gives me 0 and 1, which makes this term a 0. And then X is 0 here, so that zeroes this out, so D1 is a 0. And D2 is also 0 because X is 0. So plug in the values into these equations. Now I like to do these. Let's do one more step by step. So, you know, D1, D2, D1, D2, D1, D2, D1. Well, X is still 0 over here. Q1 is 0, so that wipes this term out. Doesn't matter what that is. Over here, X is 0, so that gives me a 0. D2, X is 0 at this spot in the state table, so that wipes it out. Let's look over here. And again, this is easy because it's D flip-flops, and the value of D is the next state. So we just write it in directly. The next example, we're going to see a JK flip-flop. It's a little more complicated because sometimes the next state depends on what you're coming from. Sometimes you toggle, sometimes you stay the same. So I'll show you how to deal with that situation. I like to go with these and reason through them. So I can do D2 very quickly here, and I know the next two are going to be 0 because D2, X is 0 right here. So there's my values for D2. D1, X is 0, so I don't have to look at that. And I'm left with just Q1, Q2 naught. So this is the only row where I have a 1. And this last row, plugging in 1, 1 here, gives me 1, 0 after I negate the 1. We've already said that's 0, so this is 0. Over here, looking at D2, again, I'm doing that one just because it's easier, quick. X is a 1 all the way down for this whole column. So we're just going to take the value of Q1. If Q1 is a 1, we get a 1. If it's a 0, we get a 0. So we have 0, 0, 1, 1 here. D1. This one's a little more complicated, but you can leave off, forget about the X because it's a 1. So it's going to depend on everything else. So wherever Q1 is a 0, I'll get a 1 because that makes this term a 1, and 1 or anything becomes a 1. So I get a 1 right here and a 1 right here. Right here, we have 1, 0 negated becomes a 1. That's a 1. Q1 naught zeroes this one out, and then Q2 naught zeroes that term out, so that's a 0. There you go. There's your state table. And now you can fill out the state graph or the timing trace. All right, so as promised, let's look at a JK flip-flop example. And this will be our last example. And this is figure 6.24 on page 381. So here's our circuit. Got JK flip-flops in both positions. So JA, I put a subscript here to keep these separate. JA is X, KA is X, and B naught. Notice here that the states are labeled A's and B's instead of Q's with subscripts. That's fine. Be consistent. Use what's in the circuit. That's the way it's labeled here. That's the way you should label it. KB and JB are the same thing. They're both the output of this gate, and this gate's output is A naught or X. And finally, Z is equal to B or A. So JA is equal to X, JB is equal to XB naught, sorry, KA. JB is equal to X or A naught, and KB is equal to same thing, X or A naught. I should have stopped and asked you the question, is that a Moore or a Mealy model? But it's Moore again. There's no X here. So that's step 1. State table. Sorry. Okay, so there's our state table. We can very easily fill out Z already. It's A or B. So we're going to add some columns for J's and K's over here. You can also put it in a separate table. So how do we get these values? Well, we've got an equation. We just plug in the values. At this spot right here, A is 0, B is 0, X is 0. At this spot down here, X is still 0, A is 1, B is 1. So because X is 0 and JA is equal to X, JA is going to be equal to 0 all the way down. KA is equal to X B naught, so this will be zeros all the way down. These are equal to X or A naught. So the X is 0, so it goes away. So we're really just looking at A naught here. And they're both the same. So again, we don't plug these values right in over here because these tell us what happens. When we're in this state and we know what J and K are, then we can know what the next state is. Over here, X is 1, so JA will be 1 all the way down. 1 here for KA, so we just take the value of B naught. And then over here, X is 1 for all these, so it doesn't matter what A is. Recall now how the flip-flop works. And we'll apply it over here. So 0, 0 is stay, stay, stay. You don't have to write this in, but I'm writing it in. This is toggle, stay, and stay. All these 1, 1s are toggles. This is set, this is toggle, and this is set. So now you apply this to the appropriate information over here, excuse me. So these two values here determine this value of A next here, and we're at stay. Remember, this is A next, B next, A next, B next. So those were the JAs. These values here for X equals 0 determine this value, which is toggle. So we got a 1. And just map it all the way down. So this 0, 0 says this 0 is going to stay. This 1 is going to toggle to a 0. This 1 is going to stay. And this 1 is going to stay. This 0 is going to stay. This 1 is... Oh, sorry. I looked at the wrong ones there. It'll happen if you go too quick. These 0, 0s determine this value here. This 0, 0 determines this value of 1. I'm not going to draw any more arrows because it'll get a little bit complicated. But here, the JA and KA are toggle, so this 0 becomes a 1. This 0 gets set, doesn't matter what it is, it becomes a 1. Toggle, and set. Now we're over here. All 4 rows are toggle here, so I can just reverse this whole column. And now you can do the state graph and the timing trace. So that is sequential analysis. And the next video will be on quiz 5 and 6, kind of tie everything together that we've covered on sequential systems. Thank you.